So my program uses Python to perform data acquisition from a National Instruments 9215 data acquisition card. I sample voltage at a rate of 1000 samples per second and plot the frequency, time domain and the frequency domain signal in real time. So here you can see the voltage is a sinusoidal signal as you'd expect. I can scale it up and down, and you can see that the y-axis scales automatically. I can also manually scale and choose what part of the signal I want to focus on. The same for y-axis. If I go back here and if I change this to 10, this also lets me save a snapshot of my signal should I choose to look at it at a later point in time. It also lets me look at the signal in real time in the frequency domain. So if we manually scale it to 100, you see that there is a peak at 60, which means that the signal we're looking at is a 60 Hz signal, which is the case for voltage signal in the US. So let's go back to the time domain. And one of the problems that we have in signal processing is to have your data in a readable format so any program can process it. So to make it simpler, for that purpose, I added a write feature which writes the information that's been collected into CSV files. And if you can look at here, the information is being updated, and a time domain data1.csv file has been created, and I've had it arranged such that every time the file reaches half megabytes, it creates a new file. So this is data2.csv, and if I go back here and go to the frequency domain, you'll see that a new file called frequency domain data1.csv has been created. And if I stop writing, so you'll see that it'll stop updating the file.